In this video, we are going to determine the final temperature and the final pressure of an ideal gas that is compressed isothermally. So the question says, an ideal gas at 17 degrees Celsius of 760 millimeters of mercury is compressed isothermally until its volume is halved. The question is, calculate the final pressure and temperature. So here, what we are going to do is, let us come up with the data. So this is the data that we have is the temperature, which is T1, 17 degrees Celsius. Then the pressure 1, which is the initial pressure, is equal to 760 millimeters of mercury. So from here, what else are we given here? The V1. V1, let us represent it, or rather, let it be represented by V0. Then when it is compressed isothermally, the volume is halved. So since the process is isothermal, we have the temperature is constant. So T initial is equal to T final, of which this is our T. So the T initial is equal to 17 degrees Celsius. So this tells us the T2 must be equal to 17 degrees Celsius in an isothermal process. So we can conclude to say T2 is equal to 17 degrees Celsius. So this is the answer for the first part. Now, the second part wants us to find the pressure, of which we know that the pressure and volume, the PV must be constant. The PV must be constant. If this be true, it holds that P1 V1 is equal to P2 V2. So here, since we want to find the pressure 2, so we're going to divide by V2 here, even here by V2. So that this and this will cancel, and what we're going to have is our P2 is going to be V1 over V2. So we plug in the values. So the P1 we have 760 millimeters of mercury times the V1, which is simply this, over the V2. Okay, so this is the V2, which is 0.5 V0. So that V0 and V0 will cancel. And what we're going to have is simply this, and 760 millimeters of mercury over 0.5. What we're going to get is 1520 millimeters of mercury.